I'd like to thank Core Marine for inviting me to speak on carbon capture solutions today. But allow me one slide on my company. Wärtsilä was founded 191 years ago. We are listed in Finland, and we are, like Trelleborg, pretty much present around the globe. So this is what we are actually going to discuss and what we are all thinking about these days. It's the green future, and in particular the green future of conventional fuels, because conventional fuels, and I include LNG because it's fossil, it's going to be around for many, many years, and we need to do something with that portion of shipping. We can't wait for all the alternative fuels to be available in copious amounts and everywhere around the world. This vessel you see, I will present a little bit more closely towards the end, but this vessel, as you can see on the right, has 4 different abatement systems. So it has a scrubber that removes SOx, it has EGR that removes NOx to Tier 3 compliance, and the vessel was built in 2019, and now during the 5-year docking we installed a particulate matter filter that removes a lot of the PM, and of course the topic of the day, CCS system that removes a little bit more than 70% of the CO2. Considering this is a conventional vessel with a 2-stroke heavy fuel oil engine, I think these numbers are very nice, and I think we can go quite a bit sorry, into the future with these numbers. I'm going to start out by touching some of the challenges around onboard carbon capture, one of them being the infrastructure. I have stolen this illustration from ABS because it shows that we don't need a separate infrastructure for maritime carbon capture. We can just piggyback on what is being developed for land-based carbon capture, and we will fit in nicely into that structure. And it's maybe not that far ahead that we have a solution for these things, because I have stolen another illustration. This one is from OGCI, the Oil and Gas Climate Initiative. They keep track of all the CCUS hubs around the world, and a year ago it was close to 280 hubs in 56 countries. So this is a very good starting point. The other thing is, of course, the regulations, and the other part is going to be the legislative side of CCS. This is just an illustration. It is the EU ETS, which is the first financial incentive that acknowledges carbon capture. It started January 1st, 2024, so it's been in operation for almost 2 years. We are hoping for more acknowledgement of CCS. We are not, of course, happy with last week's decision in London. Another topic of great importance is the custodianship of CO2 that you capture. Who owns the CO2 at which point? Not going to go into detail, but this will be a topic going forward. The last challenge is going to be the purity of the CO2. This is just a snip from what is called Northern Lights specification. It requires 99.8% CO2 in what you deliver, and that's straightforward. The problem is, as you may have heard, the NOx level, 1.5 ppm of NOx. And that's not because you pollute the CO2, it's because they made all their piping in black steel, so they're afraid of corrosion. So they transfer that challenge to the capture. That, I think we will see a development here. We will see that there will be a competitive landscape, and I think Northern Lights, they are the first movers, but they are painting themselves into a corner with these very, very strict specifications. A little bit about our development. This is a picture from our test facility in Moss, outside Oslo in Norway, where we have developed our carbon capture system. This system is powered by, obviously, a Wärtsilä engine, a heavy fuel oil engine, 1 megawatt, and this plant captures 10 tons of CO2 per day. And it has all the bells and whistles, and also a liquefaction unit, so we are producing liquid CO2, as you see in the tank outside. I guess a lot of you attending here, you have seen this process of liquid absorption or amine-based carbon capture, so I'm not going to go into detail. We can do the questions if you have them. Part of this development is, as I mentioned, PM removal or particulate matter removal, because the purer the exhaust is, the better the CCS is. So we use the scrubber to clean the exhaust, and then we use this PM filter to further clean the exhaust before we do the CCS. And as you can see, it clearly works because it collects a lot of PM and dust and ash from the exhaust. So that is developed along with the CCS, and it's working actually so well that it proves to be a product of its own. There's a lot of discussion about energy requirements when it comes to onboard carbon capture. As we see it in Wärtsilä, we need energy in two forms. We need some electricity to run the pumps, the fans, and the liquefaction. That is a need for about 10%, meaning if you have a 10 megawatt engine, you need about 1 megawatt of electricity to run that CCS system, given that you are capturing as much CO2 as possible. The big consumer is, of course, heat, because part of the process is to heat up this liquid solvent and strip off the CO2. With the same example, a 10 megawatt engine where you are capturing as much CO2 as you can, you are going to need about 3 megawatts of heat. That heat is, of course, possible to find on board as waste heat. So in that sense, your fuel penalty when operating CCS is going to be the 10%, not the heat. A lot of development going on when it comes to solvents. We are running on what's called an open source amine, because shipping is global, so we want our customers to be able to source this solvent anywhere in the world to a reasonable price. But I think we will see a lot of development over the next 10, 20 years on solvents. They're going to be more effective, less energy consuming, more environmentally friendly. So this is just a starting point, in my opinion. Okay, so this pilot vessel that we started out with, this is how it looked before fitting the CCS. We did pre-fabricate this carbon capture unit as a backpack, and we, as you will see on the next picture, we fit that at the back of the funnel casing. We were able to find space on deck for 2 liquid CO2 tanks, in spite of this deck space being fairly busy and crowded. So here's a picture to compare. You can see the CCS in the back, and you can see the 2 liquid CO2 tanks on deck. I have to say that this vessel is an LPG carrier, so most of the piping that you see is for cargo handling. So the CCS is not as bad as it might look on this picture. Dimensioning the tanks is project specific, I would say. It depends how much CO2 you want to capture. Of course, how long your voyage is, how frequently you can discharge. This vessel wanted to capture as much CO2 as possible and be able to sail across the Atlantic. That takes 20 days. The system captures about 50 tons CO2 per day, and therefore the tanks are able to accommodate about 800 tons of liquid CO2 before they need to discharge. This is just an illustration from building this backpack in the yard, prefabricate this one, so that it's much quicker to install once the ship arrives at the yard. Tanks are quite sizable in this project, and this is a retrofit. In new builds, you can also make deck tanks and structure tanks in the hull, if needed. Lifting tanks on board. And then just a view on board. Again, most of the piping is due to cargo handling. So, to wrap up, this first full-scale CCS system captures around 50 tons a day. It captures about 70% of the CO2 from all combustion units on board, main engine, auxiliary engines, and boiler. Thank you.